One last thing with factoring polynomials is factoring by substitution. Sometimes we have a polynomial that does not factor easily or can look kind of ugly. So let's look at an example of that. Let's do 4 times 3p plus 2 squared plus 14 times 3p plus 2 plus 12. Now, I'm looking at that and that does not look pretty to me. But I do notice something. I have 3p plus 2 squared, I have 3p plus 2 to the 1, and I have 3p plus 2 to the 0, right? It doesn't occur there. So I can use substitution. I can say, well, instead of treating this like 3p plus 2, why don't I let u equal 3p plus 2? If I do that, I can rewrite this as 4u squared plus 14u plus 12. Well, that doesn't look so bad. In fact, I look at that and I go, I got 4, 14, and 12. Well, I can factor out a 2. Greatest common factor, right? So 2u squared plus 7u plus 6. Well, this is looking even better. So now, if I'm going to factor this, I'm going to factor by grouping. These aren't perfect squares, so I can't do it that way. But factor by grouping, I can say, well, 2 times 6 is 12. So I have two numbers that multiply to 12 and add to 7. Well, I look at that and I go, well, that's got to be 3 and 4. 3 plus 4 is 7. 3 times 4 is 12. So that's 3 and 4. So I can rewrite this as, and don't lose that 2 on the outside. In fact, what I'm going to do is I'm going to use a square bracket just so I can deal with this and keep that separate. So I have 2u squared plus 3u plus 4u plus 6. Keep that 2 out there. Factor out a u times 2u plus 3. Factor out a 2 plus 2 times 2u plus 3. Well, that works out nicely, giving me 2 times 2u plus 3 times u plus 2. Okay, I know that's kind of low on the bottom there. So I'm going to bring that up here. I'm going to change colors just so it doesn't blend in as much. So I have 2 times 2u plus 3 times u plus 2. But now I have to do that final part of substituting 3p plus 2 back into this. So I have 2 times 3p plus 2 plus 3. Actually, let me write that a little better there. Because u is 3p plus 2, so I want 2 times, I'm going to put a bracket, 2 times 3p plus 2 plus 3 times 3p plus 2 plus 2. Now I can distribute that through, so I have 2 times 6p plus 4 plus 3 and 3p plus 2 plus 2. 2 times 6p, let me make that a parenthesis, I don't want to do a square bracket anymore. 6p plus 4 plus 3 is 6p plus 7. And 3p plus 2 plus 2 is 3p plus 4. And we have now factored this thing down into that. We did it by substitution. We saw that we had something that was being raised to a second power, raised to the single power, and not in the last one. So we were able to substitute for a simple variable, which made this part of it really easy. And then we just substituted back in and did the multiplication to turn it into factors, because this would not be considered factored because we have all these operations and multiplications and additions going on in there. So we needed to multiply that out and simplify it to get us to our final result of 2 times 6p plus 7 times 3p plus 4. So that's our final method for factoring polynomials, is sometimes we have something big and ugly and we can simplify it this way. A lot of times what you'll see is even things where you have not as ugly as this, but you just kind of look at it and go, what? Can even be something as simple as x to the 6th plus 2x cubed minus $15. And you look at that and go, well, whoa, we got x to the 6th, x cubed. How do we do that? That's not our standard trinomial, but it is a trinomial. It's not a quadratic, so what do? And we look at this and go, well, wait a second. If I let u equal x cubed, then I have x squared plus 2x, sorry, not x squared, u squared plus 2u minus 15. Two numbers that multiply to negative 15 and add to positive 2. That would be positive 5 and negative 3. So that's just, since that's u squared plus 2u minus 15, that's u plus 5, u minus 3. Now we substitute back in x cubed. So we have x cubed plus 5, x cubed minus 3, and we're done. So you can see how even something like that can be simplified relatively easily by using substitution.